Welcome back, my name's Eric, let's get right into it. Today, we're tackling LeetCode problem number 217, contains duplicate. Given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. We need to check for the repeating numbers within the array. Key constraints include the size of the array and the range of the integer values it can contain. We must also handle edge cases such as an empty array or an array with all identical elements. The most straightforward way to solve this is by using two nested loops to compare each element with every other element in the array. So start off by creating a for loop with the pointer I. We're also going to put a second for loop with the pointer j inside of this for loop. Now we're going to check nums I is equal to nums j, and if a duplicate is found, we're going to return true. After checking all possible pairs, if no duplicates are found, we're going to return false. Let's test the code. Now, while this code works, its time complexity is big O of n squared, which really isn't ideal for large datasets as it's very inefficient. Now, let's explore a more optimized solution that reduces the time complexity significantly in only one line of code. And all we have to do is create a new set for the array nums. Now, we're just going to return size check equal to nums.length. And that's it. The reason this works is that sets automatically store only unique values. By comparing the size of the set to the length of the array, we can determine if there are any duplicates. And if the sizes differ, it means that there are duplicate elements, and we return true. Otherwise, we return false. You can see here our runtime is only 47 milliseconds compared to when it was 76 before. This improvement in runtime is due to this time and space complexity. Understanding these is very crucial for evaluating the performance of our algorithms, especially when dealing with large datasets. For the time complexity, our solution achieves linear time complexity because we traverse the array only once to create the set, and represents the number of elements in the input array. This means that the execution time grows linearly with the size of the input, which is highly efficient for most practical scenarios. For the space complexity, in terms of space usage, we're looking at a linear space complexity of big O of n. In the worst case scenario where all elements in the input array are unique, we end up storing all n elements in the set. This trade-off between time and space is often acceptable as it allows us to achieve our desired time complexity. This optimized approach is way faster compared to our original nested loop solution, especially for large input sizes. It's worth noting that the actual performance may vary slightly depending on the specific implementation and the characteristics of the input data. If you found this tutorial helpful, please give a thumbs up, subscribe, or even leave a comment below with the next LeetCode problem you'd like me to cover.